And hello, welcome back. Today we're going to be looking at another Leetcode interview problem. This is problem number 1 on Leetcode. This is two sum, a very popular problem. So let's read the description and then we'll get into the actual implementation of the solution. So the description says, given an array of integers nums and an integer target, we want to return the indices of the two numbers such that they add up to the target. We're told that there will always be exactly one solution and that it won't use the same element twice, which means that we don't have to worry about the base case where there is no solution. We know that there's always going to be exactly one solution. Knowing that these can be returned in any order is nice, so we don't have to worry about which one comes first and which one comes second in our return. Let's see an example to make sure we know what's going on. So in this example number 1, we're given the input where we have nums is equal to the array 2, 7, 11, and 15, and our target is 9. So just by looking at this, we know that we want 9 to be our total, and the only numbers that could add up to 9 in this are 2 and 7. So that's our answer here, is the number at the 0 index and the 1 index. So that's their reasoning for the result as well. Let's go ahead and think about how we can actually implement this. So just at a first glance, you might think that this would be an O of n squared runtime, like we would need to iterate twice through the array, once per number and then once per other option to add up to 9. So we would say, okay, we would look at 2 and say for each number in the array, can 2 plus this number add up to 9? And in this case, that would work out. But say these didn't work out, we would move on to 11, say, and we would say, okay, 11 plus 2, that doesn't add up to 9. 11 plus 7, that doesn't add up to 9. And we would need to check each number. We should actually be able to do a little bit better than that. We should be able to use a hash map or a dictionary and store what indices each of these numbers are at, so we can actually do this in linear time. We only need to go through the array once, and we can store each number previous and check against our hash map to see if we have a solution based on our current number and the previous numbers that we've seen. So let's go ahead and start setting this up. We don't have to worry about base cases like we said, because there's exactly one solution. So let's start with building our hash map. So we're just going to say hmap equals open closed curly braces. This is all we need for a hash map. And then we want to go through every number in nums, and we want to have the number and the index that it's in. So we're going to say for index and num in, and instead of a for loop, we're actually going to enumerate. And this gives us the index and the num that we're on in nums, which is really handy. So we have each index and the corresponding number in the array nums. So what do we want to do with this? Well, for each of these, we want to check if our current number that we're on has the matching number that adds up to our target in the hash map already. And this hash map is going to be storing the number with the index that it's in. So we're going to check if our hash map, or rather, let's do this. So if our target number minus the number that we're on, that would be the difference. So if this number, the corresponding number to this one is going to be target minus num, because num plus whatever target minus num is will always add up to target. So if number minus, or if target minus num is in our hash map keys, which we can just get by doing hash map dot keys, then we know we've found a solution. And that might seem kind of confusing. I can explain that a little more. So our hash map keys are going to be all of the previous numbers that we've already seen. And we know that if this number is equal to target minus num, then when we add those together, they're going to equal target, which is our solution. So num and target minus num are going to be our return value here. So that's exactly what we want to do here. We want to just return a new array, and this is going to be target minus, no, I'm sorry, not target minus num. This is the index that we're on now, because that's the index of num, and then the index of target minus num is going to be the value in our hash map. It's going to be hash map at target minus num. Okay, and then if this is not in hashmap.keys, that means that this isn't a solution yet, but it could be the solution of a future number in our array. So we want to add this to the hash map. So we're going to add that here. We're going to say hash map at num just equals our current index. That way we can get to this later and we can check it against future numbers in the array. And that's actually the whole solution. There's nothing else to it. We don't need to check for base cases. There's no other part that we need. This will always get to a return statement because we're told there's exactly one solution. Let's go ahead and run this just to make sure and see how it does. All right, so there you go. It works, and this is the finished solution. It's a pretty cool problem, and thank you so much for watching. I will see you in the next video.